All right, let's go ahead and just focus on demonstrating whether something is a binomial experiment or not. And if it is a binomial experiment, I want to specify what my random variable is, right? What the variable of interest is. So we need to ensure that we meet the four conditions established before, which are here. Condition one, you have a fixed number of trials. Condition two, you have independence of the trials. Condition three, there are two mutually exclusive outcomes. And the last condition is that the trials are independent. So consider the following situation and determine whether the scenario is a binomial experiment or not. So you're going to flip 10 coins all at once, and you're going to record the number of tails that were observed. So let's note here that your random variable of interest is x, which is the number of tails observed. So you want to observe tails whenever you flip a coin. So is this binomial or not? So let's see. Condition number one, do you have a fixed number of times that you're going to do this? And the answer is yes. I'm flipping 10 coins. So fixed trials. And notationally, I'm going to go ahead and already push the notation that we're going to be using. So the notation, when you've got the number of trials, that's going to be n. Number of successes, that's your random variable. So that's going to be little x. It's a specific value. The probability of success, or yes, that'll be p. And then the probability of failure, that's 1 minus p. So for us, the main thing that we'll need is p, the probability of success, and then n, the number of trials, because that's what we need for the applet. So we're always going to be after n and p. All right. So for C1, fixed number of trials, that basically means n is 10. So we're good on that. Condition two, do we have independence? And it's going to be yes, because we know that a coin flip or like a die roll are independent, right? What happens the first time will not influence future times. All right. C3 was two outcomes. And yeah, we got that because the outcome can either be heads for each flip or it could be tails. And there's no in between. All right. And then finally, condition four, do we have equal probability of success? Per trial. In other words, per coin flip. And the answer is yes. We do. All right. And the probability of success would be 1/2, right? 0.5. Awesome. So flipping 10 coins at once and then counting the number of tails that are observed, that is a binomial random variable. So you can find all that you want to know by using the applet. All right, B, you're going to draw 3 cards from a standard deck of cards, and you record the number of red cards in your hand. So pause the video and see if you can work through this one. This one's a little bit challenging. We'll go ahead and see why. All right, so hopefully you tried this already. Let me write these in. Condition 2, independence of trials. Condition 3, are there 2 outcomes? And condition 4. Or instead of saying equal probability, because that sounds misleading, maybe let me say same probability of success per trial. All right, so hopefully the first one you went ahead and already recognized that, yeah, this thing here that you're doing, you're going to record the number of red cards in your hand. You're going to draw 3 of them. So that tells you that, yeah, you're doing this 3 times. You're going to draw 3 cards 3 times. Now, the easy one here would be 2 outcomes, because the outcomes that we've got when you draw a card, you're either going to get red or you're going to get a black card. And so that's true. Now, the question for independence and same probability is not clear in this example. So C2 and C4 are actually only met if you're drawing with replacement. Because let's say you get a red card the first time. If the first time you get a red card and you keep that card, then the next card that you get, right, the probability of getting a red initially is 0.5. And that comes from two suits of cards. So that's 26 cards out of 52 are red. But if you keep that red card there, the probability of success would then be 25 over 51. So you don't have the same probability every single trial of success for every single trial. So that means that what happens first is in fact influencing what happens later. So condition 2 and 4 are only met if you're drawing with replacement. So that one was a trick one right there. All right, so thank you for this. Let's go ahead and leave part C for you. Historically, 85% of people have liked your commercials. Your company just produced a new one and presented it to the focus group of 18 individuals. They record how many respond favorably to it. So go ahead and show why this is a binomial experiment. I'll leave it for you. So we're talking about people liking commercials from like some company. Think of like maybe the Doritos commercials or the Carl's Jr. commercials. Is that how you spell Carl Jr.? Carl? Or, for example, the Allstate commercials. Or is it State Farm? Anyway, we'll go ahead and talk about that later on. All right, just really quickly, D and E. So we already saw that E, you ask all students in the class, have you watched the series blank? Would that result in a random variable? Yes or no? So think of that. Think of that one. Now here's D. You asked 20 Glendale students what their favorite color gumball is. So if you run through that, C1 is correct and it's 20. C3 is correct because there's, or sorry, not C3. The independence could be yes. If you take a simple random sample. But by the time you get to C3, which is the two outcomes, success or failure, this is not met because you don't just have two outcomes. Because you're asking the student an open-ended question, what is their favorite color gumball? They could give you any colors that they want. And so we don't have these two mutually exclusive outcomes. So the only experiment here that is not binomial is D. Awesome. So thank you so much. This shows you how you can verify that an experiment is binomial. And we'll go ahead and talk about how to find probabilities and expectation in the next video.